TrueDepth, a Blender add-on for turning 2D images into 3D models using monocular depth estimation, has got a big update. Version 3 includes, in addition to the displacement mode, the perspective and the HDRI modes, and some pretty cool new features as well. So it's time to update our TrueDepth tutorial. TrueDepth uses the second generation of the Depth Anything machine learning model for monocular depth estimation. It was trained on a synthetic data or photo scans, but also on data scraped from the internet. All it learns is how to estimate depth, not generate artworks or imitate artist styles. However, whether that's acceptable, it's up to you. There are also potential licensing issues. Do your research before using it commercially. Alright, how to install it? After downloading it from Superhive, you go Preferences, Add-ons, and then we can simply drag the zip archive over there, click OK, and search for TrueDepth to make sure we have installed it. If you are updating TrueDepth, make sure to uninstall the previous version first. I would also wipe out the entire folder with its remnants. In Windows, it's usually located in C, Users, TrueDepth something, or check the path in the add-on settings. Then we have to install the dependencies for CPU and GPU. Click Install, it will go through this process. And then the same for GPU. It might look dreadful if you haven't done that before. And after that's done, reopen Blender. Now once we open the sidebar and scroll down using the mouse wheel, we should be able to find TrueDepth there. Now the models shown there have to be installed too. Previously we've had to download it manually from GitHub, and it wasn't a big deal. But now we can just click Download Model, and it will get it downloaded. I'll get it all, including the large one, and we should be good to go. Officially, the large model is non-commercial use only, as well as the base model, while the small one is available for commercial use, but again, that's a bit of an uncharted territory, so do your research. Technically, the large model should produce sharper, more precise results, but actually the smallest one is also pretty good, as in definitely usable. So, Depth Anything, the second generation. What is this thing? It is a widely used monocular depth estimation model capable of predicting depth from a single image. That's what monocular means anyway. It was trained on photogrammetry or labeled datasets and 2D images datasets or unlabeled. Usually the AI researchers question this part, while photogrammetry or structure from motion is being considered fair game. To use Depth Anything, you don't have to own the TrueDepth add-on. For instance, it's available on Hugging Face, so you can compute depth there for free. The caveat is that it's A, low res, and B, it's 8-bit output, which leads to bending when used for displacement. Alternatively, you can use it locally by downloading the thing from GitHub. I'll leave the instructions in the description. The pro of using it locally is that you can crank up the resolution. But again, the default repository still uses 8-bit output, at least as for today. There are custom forks on GitHub that force it to write 16-bit files, yet I actually went in and tweaked the run.py file within the Depth Anything folder. It's what you get when you install the official repository locally. The original file supported just 8-bit with 256 colors, and here I added a 16-bit file support with 65,000 gray levels. And you won't believe it, it worked! I'll drop the link to that updated file. The issue with trying to fit all details into high-resolution depth map is that it requires a lot of VRAM. For instance, I ran out of VRAM trying to calculate the 2048 depth map on my GPU that has 11 GB of VRAM. Actually, TrueDepth goes in a completely different direction and approaches the stepping issue in a completely different way without pushing the resolution and VRAM limits. It's pretty interesting, and we'll talk about that in a moment. Alright, let's get out of the weeds and see what the new version of TrueDepth has to offer. Version 3 or not, the main mode of using TrueDepth is still flat relief. It's peculiarly called like that, but it's actually 3D relief generated from a single image. I'm gonna use the largest model size available, 32-bit accuracy, and I'll simply click Open, and here I have a small collection of rocky images. I'll put it into pure ref so I can zoom in and see it in full resolution and choose the one that I like. This one, for instance. So I'll just click Open Image, then we can store depth map beside the original image and hit Generate Depth Map right away, and after a few seconds we should see our depth map right here. The further away the pixel is, the darker. Instead of grayscale, we can use fancy color palettes, if only for aesthetic reasons, you know, because they perform a little bit worse than grayscale palettes, so not recommended for actual production. As we've mentioned, the depth maps are stored in the same folder beside the source files. This menu is for choosing modes, and currently we are in the flat relief mode, and we can simply click create mesh and the mesh will appear. Okay, we generated some depth, now we need some proper lighting to emphasize it. I will toggle the rendered mode right away, and we are in Eevee. The environment light can be made a bit brighter, and don't forget ray tracing if it's Eevee. Now it's the matter of adding a stronger key light. It can be the sun or the area light, doesn't matter. Here we just need some sort of a kick to emphasize that shape and that relief. Again, the position of that sunlight or area light or whatever is really important. One of the best ways to position it is to place it on the opposite side relative to the camera, and it holds true for all render engines. As you may know already, it's called the reverse key lighting, and it's almost always more three-dimensional than the light placed on the camera side. It's the axiom of cinematic lighting. The far side light paints a more three-dimensional relief. Now, true depth basic settings. Let's have a look at this panel, true depth modifier properties. The first thing that you usually do is increase resolution or the number of subdivisions. It makes the displacement much more detailed, but keep track of the poly count. If your computer allows, you can push it to literally millions of polygons, if you crank up the levels to 6 and more. Thankfully, due to the recent improvements to Blender performance, it has been getting better and better as for rendering multiple GPU subdivisions. You can even override this field and input your own value here, like 7. And guess what? It will get even more detailed. And the light will reveal these details on Durin's day. Okay, I'll put it back to 6. You know what? Let's talk about displacement frequencies. It's one of the things True Depth does differently. In True Depth, we have the displacement depth, which is the base displacement, and then we have displacement detail. Let's zero it out, both the detail and the base. So now we are left with a flat surface. So this slider is the base displacement strength, or the low frequency. And this one is the higher frequency detail on top of that. You know, the spiky, detailed undulations. Usually it's wise to keep both these sliders at bay, especially the detailed one. Otherwise, you may notice a lot of stretching if you push these sliders too far, or a lot of unpleasant spikiness, let's put it like that. To help with that to a certain extent, there is the smooth slider. Actually, to see it better, let's switch to the solid shading mode. If you crank it up higher, you will notice the smoothing effect applied to geometry, and it's also about the factor. So you see what it does. I think I'll stick to the default values though. In addition to these two frequencies, we have the extra high frequency, which is the bump mapping in shader. This is where a really fine grain is applied. It should also be approached with a certain degree of moderation. But it's a pretty cool way to add that extra pinch of detail on top of these two previous levels. Interestingly, the base displacement level or the low frequency displacement is driven by the depth map, and the detail displacement is driven by the color map instead. This is the current paradigm as how True Depth approaches this. It splits it into different levels of detail. Okay, the next useful feature is correcting tilt and distortion. You know, sometimes geometry ends up tilted one way or the other. The tilt correction or on distortion slider, if you set it to say 1, helps to correct that. By correct, I mean straightening it out like that. Sometimes depth ends up tilted like that, you know, horizontally. Again, this slider comes to the rescue. Generate depth map again, and it should be corrected. Ultimately, it very much depends on the image. Various images have various distortion types, and for some of them, you may want to correct them in something like Photopia or other image editing tool, for instance, to remove that 2D tilt. Just like that, and it will already translate to a better depth map. Now, a few words about modifier stack and interoperability. All these sliders and settings within the True Depth interface are actually hooked up to modifiers. All these things, you know. If you open the modifiers tab, you'll see it there. Actually, let me disable them one by one. This is where it gets subdivision surface, the base displacement, the detail displacement after that, and the rest of it, basically. The TD base, or the last one, is where the object gets manifold shape. You know, what makes it watertight. We'll talk about that later on in the context of 3D printing. Now, if you're happy with this object and you just want to export it out to different application or whatnot, you can right-click and go Convert to Mesh, and it will collapse the modifier stack. So it becomes just a 3D object. Now, how to use TrueDepth add-on in the context of seamless PBR workflow? Tileable textures like on Polyhaven and all that. Well, first of all, you have to use the seamless textures as the source inputs for TrueDepth. Otherwise, naturally, the output geometry will also have seams. How to make any texture seamless? Well, one of the ways is to use GIMP. Filters, map, tile seamless. Well, this method is a bit simplistic, but it will work. Alternatively, we can use something like Photopia to offset a copy of our image and paint over the seam with a soft brush to erase it. And here we go. Or if you still use Photoshop, you can use something like Generative Fill to extend your image. Just type extend this texture or whatever. By the way, Firefly has not been scraping internet, but that's another discussion. And then after offsetting this image, the resulting seam can be painted over using the Content Aware Fill. That's a pretty quick way of doing it. But even then, there's one more step to making depth map truly seamless. Alright, so here we start with a seamless color texture. We know it's seamless, we made it so, and we generated depth map now. It should be seamless as well, right? Actually no, we need to use the extra Make Seamless feature. Vertical blend sets the vertical blending, while the horizontal is fixed. A little peculiarity, but anyway, we need to click Make Seamless and enjoy our truly seamless depth map. We can prove it really easily by updating our mesh. And now simply Shift D to duplicate and place it nearby, and it should tile seamlessly. So it's a nice little feature, nice little helper. Without it, we would still have been able to see the seam. I made a PBR setup for using maps generated by TrueDepth add-on, and you can download it from Creative Shrimp. After you open the blend file, you'll see this shader. It's not very complicated. It has a base color, your source texture. It needs to be seamless, of course. If you want it to repeat, its color space should be sRGB. And then you have the depth texture exported from TrueDepth. It should also be seamless. Its color space should be non-color, because if you set it to sRGB accidentally, it will look wrong. So make sure to stick to non-color, because it's a data texture. Next, if you scroll right and find the displacement node, it's where you control the base displacement strength, just like in TrueDepth. Again, this whole thing is just depth map being used as displacement. Otherwise, it would be a finely tessellated flat plane. Its actual tessellation is controlled in the Modifiers tab. Even with the lower subdivisions, it would still look plausible because of the bump map being used, but obviously the more subdivisions, the higher the detailization. Actually, this shader setup is render engine agnostic. It works in both cycles and AV. It produces beautiful results, and it works really fast in AV. Then the higher frequency detail is controlled over there. It follows the TrueDepth logic of splitting the low and high frequency detail. To be able to see it slightly better, let me switch off the base color for a moment. So this slider is the fine grain on top of that base displacement level. It's important to not overdrive it, otherwise it will look funky. And here I have my modification to it, and I'm very proud of it. As a quick reminder, the way that extra level of detail is set up in TrueDepth is that it actually uses color as displacement, as opposed to the base displacement layer, which is driven by depth map. So sometimes these extra details look spiky, and this innovation of mine kind of prevents that. Well, of course it's different from material to material, but I find this slope to work pretty well in most of the cases. Now let me bring back the base color. And actually, in the final version of the shader, you will also see the bump map plugged in there. This is the purely shading level of detail that is also present in the TrueDepth approach. Anyway, the final thing I wanted to mention is that, of course, here we have the mapping node that allows you to change the texture mapping For instance, if you want to see how seamless are your textures indeed. I hope you find it useful, this little shader that I made for rendering the true depth seamless textures. The next mode that was introduced in version 3 is perspective. You still have to select a source file, this city for example, a photo from Unsplash, and hit generate depth map. Then before hitting create mesh, choose perspective as the mode and set the field of view. It should roughly, and I mean very roughly, correspond to the focal length of the lens used for taking this photo. Then if you aim for realistic results, the mapping should be inverse. I'll leave the rest of the settings, including grid resolution, to their defaults. And shadeless means it will just use the original image without applying any extra shading. And now I'll just press create 3D scene. It will look stretched like that from a certain vantage point, which is not exactly known, but we can estimate it really easily. Just scroll down and click Setup Camera Projection, and it will create a few cameras. One for projecting that source image onto geometry, and another one for the camera view. If the render result or the viewport image looks a little bit washed out compared to the original image, that's because of the view transform. By default, Blender uses AGX or filmic view transforms. Just set it to standard if you want one-to-one match with the original image. Alright, then when working with the camera projection, I usually go to the camera settings, viewport display, and set passport 2:1. And now we can move the camera around, make all kinds of dolly zooms within certain limits, you know. We can even add some fog and stuff like that. We have 3D geometry to work with, so we can do tremendous stuff, you know. Just don't move it too far from the original point of projection, otherwise it will become slightly stretched. Apart from that, it's an amazing technique. Well, in the previous versions of True Depth, we could also simulate perspective by stretching the relief very far, but now we have a lot more control over it. For instance, we can adjust the initial grid resolution to go much more detailed than before. If you uncheck shadeless and recreate the 3D scene by clicking Create 3D Scene button, you can select from a range of surface presets, glossy floor or mirror/metal, the default one being matte. Actually, after creating an environment like that and setting up some light, you can select a part of this environment in the edit mode like that and apply material only to this part. That's pretty cool for simulating, let's say, glossy floors. Then the grid resolution and the detail displacement are connected. First, you add enough resolution, and then you crank up the detail. That's probably too much, but you got the point. Let me delete it and try a slightly lower value. Yeah, that's better. And again, we can select this floor in the edit mode and select it again with the X-ray turned on in the solid shading mode to make absolutely sure we captured everything. And voila, we have the wet floor effect going. And yes, if you move too far, you'll see stretching. Generally, the safest material for projection is the matte material that has a very low reflectivity level. The more reflective it is, the glossier it is, the easier to blow the illusion. So use a very matte material if you want to add multiple lights and stuff like that. It will hold up much better. Finally, I want to come back to mapping once again. If you switch it to linear and recreate 3D model, the result will be much more flat or flattened or, you know, just contracted. That makes it look slightly more tame and easy to work with, but it doesn't look realistic once you push into that scene. Just converges in the wrong way. If you strive for realism, just use another type of mapping, which is the inverse one. In the viewport, it would make it look weirdly stretched, but from the camera perspective, it actually looks fine. Yet another mode that was introduced in this version of True Depth is a 360 degrees dome. It's an interesting one. Let's have a look at the first variant of it, which is the HDRI Studio. Basically, the issue with the vanilla HDRI setups is that the object doesn't look integrated at all. It looks floating. That can be tweaked by using some custom node setups for cycles and DV, and I mean without True Depth, the setups that use a dome projection and probably a shadow catcher as well to make it sit better within the scene. Too bad shadow catchers don't work in Eevee just yet, but otherwise the dome projection can be achieved with the help of the shader nodes. I will share one of these setups in the description, yet I don't want to inflict these shader nodes upon you in this tutorial, because it's a little bit complicated and that's not the most versatile setup ever, but it kind of gets the job done if you want a very basic dome projection. Yet True Depth makes this process much more convenient out of the box. What you need to do is select the HDRI image, and by the way, we don't need depth map for this one. Then switch the mode to 360 degrees, then HDRI Studio. These settings can be tweaked after generating it, so I'll just go Create HDRI Dome. See? Easy. Then this object can be moved around to integrate it better, and all these parameters can be tweaked live. The ground sheen adds that reflection, you can turn it off if you want. Heading rotates it on the Z-axis. Capture height, horizon fit, and other parameters can be tweaked to taste. It is very much based on any particular HDRI, so it will be different each time. The best way is just to go ahead and test all these parameters, including wet patches and whatnot. To make it work, you need to enable ground sheen, I think. Right. It's a pretty cool way of adding some extra interest to your HDRIs. I can easily see that it could be very useful in look dev. Then you can tweak the exposure here, hide backdrop if needed, and show only the plates. It only works in cycles as well. That can be useful for compositing. If you're gonna be using Eevee for rendering this, then absolutely check the ray tracing settings, because it's what makes it look realistic. For instance, you can go without fast GI approximation, and then you can increase the thickness to add that thicker shadow underneath the car. No denoising helps to keep it sharp, I mean the Eevee's GI. And yeah, honestly, it's unbelievable how far Eevee has come. Just look at that, it looks realistic. It looks almost like it's rendered with cycles. And True Depth definitely helps to make this process a little bit more approachable. Oh, I forgot to mention that you can reduce the light output or the diffuse light contribution. Nice little feature. Another variant of this feature is called Depth Sphere. What it means is that you can, for instance, select an HDRI with the objects close to the camera, like the stony walls of this cave. If it's EXR and you try generating depth map, you will get an error, and that's a bummer, but you can easily convert HDRI to other formats supported by True Depth, just for the depth map step, I mean. Just load the EXR file into the Blender's image editor, check color management, and adjust exposure and contrast until all details in the highlights are visible, and in the shadows as well, and save it as render, as a PNG file. Here I called it proxy. Then open this proxy up, and generating depth map should lead to success now. The mode is set to 360 degrees dome, depth sphere. The mapping can be set to inverse, as it usually looks more realistic out of the box. Far distance can be adjusted to taste, and other properties as well. I'll leave the grid resolution at its default for now, and hit create. And we should see some kind of environment approximated based on our HDRI. The default resolution isn't going to be tremendous, so if you want to crank it up, increase the grid resolution a bit, all the way to 2048. Create. Now it should be slightly crispier. Not that it matters much here though. And technically, now we can navigate around our mini scene. So that's how it works. It works best when there are some objects very close to the camera in the HDRI. And now the environment still emits a lot of light. It's still an HDRI environment, so any objects placed within its context will receive that light. Now there are a few extra features I want to mention. Video mode. Snapping back to the second generation of depth anything, it can actually be used for generating depth from videos. What we need to do is select an image sequence or a video file. Click open, I'll select this Seashore MP4, uncheck save as video, otherwise the video compression will kill it. And then you can adjust the undistort factor and add flicker-free depth. Upon clicking generate, it will take some time to go through the entire sequence and generate all the depth map frames. But once it's done, you can use it as a displacement. Its quality depends very much on the source footage, whether it will be flickery and jittery. But here you go. I wonder what interesting uses you can come up with in Blender or maybe in DaVinci Resolve, you know? Then another interesting feature found in this new version is the 3D printing tab. So let's say we want to 3D print this model after displacing the relief. At the bottom of the settings, you will find the new 3D printing settings menu. It has the lithophane section here and the general mesh to a 3D print section. Upon adjusting the parameters, you can just click here to convert it to print model. It will make it guaranteed watertight, and we'll place it nearby like this. It will basically prepare it for 3D printing, as simple as that. Afterwards, you just save it as STL. Export, and enjoy your 3D print! The lithophane section is a pretty interesting one. You can set all the parameters you wish here, including the max thickness, raised frame if needed. These settings are switched off by default, so I'm going to activate this and stand upright and create lithophane. A lithophane is made of a thin translucent material. When lit from behind, it reveals an interesting texture. To conclude, we've taken a look at the new version of TrueDepth that brings a machine learning based monocular depth estimation into Blender. And while it's possible to generate the solid depth maps for free using Depth Anything online on Hugging Face, or better yet installing it locally via GitHub, TrueDepth still earns my recommendation because its integration with Blender and extra conveniences. I think all in all it's still a pretty good offer. All the links are available in the description below and on creativeshrimp.com. I hope you found it interesting. I would appreciate if you gave this video a thumbs up and subscribe to the channel. Thank you for watching, and I hope you have a great day.